Okay, so in lesson 5.5, we're going to cover a third form of linear equations, and this is called standard form. So I'm going to go over this definition at the top. The standard form of a linear equation is this ax plus by equals c, where a, b, and c are all real numbers, and that a and b both are not zero. So when we are talking about standard form is really useful when we're working with x and y intercepts. So I'm going to show you how to find x and y intercepts using standard form. First, in example 1, we're going to find the x intercept. And to help us understand that, it's important to understand that the x intercept of a graph is where that graph crosses the x-axis. So what I want you to understand is when a graph crosses the x-axis, that means it has a y value of 0. So to find the x-intercept of this equation, or of this graph, we would take the y, substitute out y, substitute in 0. So to find the x-intercept, I'm going to do 3x plus 4 times 0, which is 0, equals 24. So that really means 3x equals 24. X is 8. So my x-intercept is 8 for this equation. Now my y-intercept is just the flip side of that. The y-intercept is when the x value is 0. So 3 times 0 is 0. 4y equals 24. Y equals, if I divide both sides by 4, I get 6. So my y-intercept is 6. And that's a terrible line, but you get the idea. You only need 2 points in order to graph a line. So my y-intercept is 6, my x-intercept is 8. So we are going to use intercepts to graph a line today. So, just like we did before, find my x-intercept by substituting 0 for y, which really is just 2x equals 20. Divide both sides by 2. My x-intercept is 10. Right, my x-intercept is 10. Find my y-intercept. I substitute 0 for x. 0 for x makes this 5y equals 20. Divide both sides by 5. My y-intercept is 4. So we only need 2 points to graph a line, and I'm going to do the best I can, but it's not going to be easy to draw this as a straight line. So draw it as straight as you can. I'll give you guys rulers when you practice this on paper, but for today, it's mostly just finding intercepts, understanding vertical and horizontal lines. So when you draw your line, make sure you create a line that has arrows pointing in both directions and covers the entire grid, because that line extends to infinity in 2 directions. For example 3, I'm asking you to graph equations that are just x equals or just y equals. So it's about understanding what you're actually given. For x equals 3, you are given an x-intercept of 3. Okay? This graph has no y-intercept, which means it has to be parallel to the y-axis, which means this is a vertical line with a y-intercept of 3. So whenever you see an x equals a constant equation, that means it's a vertical line at that constant, crossing the x-axis. On the flip side, y equals 3 gives you the y-intercept. You do not have an x-intercept for this graph, so that means this never crosses the x-axis, which means it's parallel to the x-axis. So when you have an equation of y equals a constant, that is a horizontal line. Okay, horizontal line for a y equals a constant. Moving ahead, example 4 to me is a little less important. I'm still going to show you an example of this, but I'm not going to spend much time emphasizing it. Example 5 is going to be more of what I emphasize. So with example 4, converting to standard form. So just to be clear, example 4 I will cover, we will practice, but you will not be expected to replicate this on a quiz. So for example 4, y minus 2, to get this in standard form, I'm first going to distribute negative 1/3. So negative 1/3 x minus, this is going to be minus 2, because 1/3 times 6 is 2. To get this into that standard form, I need to get x and y on the same side. So my first step is going to be to add 1/3 x to both sides. So that eliminates it. So this left-hand side becomes 1/3 x plus y minus 2 equals negative 2. The important part to remember here is that these parts stayed the same. All right? Now to solve this, to just have x and y on the same side and have a constant on the other side, I'm going to add this 2 to both sides. So my equation now is 1/3 x plus y equals 0. Okay? Now, I wanted to write this using integers, which means I want to change this coefficient. We call 1/3 a coefficient on the variable x. Change that to an integer, which means I need to multiply it by something that essentially eliminates the denominator, meaning eliminates 3. So I'm going to show you what I'd multiply this entire equation by to eliminate that denominator. I'm going to multiply it by 3. So to eliminate a denominator, I just multiply by that denominator, because 3 times 1/3 is 1. So if I distribute this throughout the whole equation, because if I want to preserve, if I want to keep the equation the same, I would multiply both sides by the same thing. Kind of like how we add the same thing to both sides of an equation to keep it the same equation. So if I multiply everything by 3, this becomes x plus 3y equals 0, because 3 times 0 is just 0. So that's what I would accept as writing it in standard form using integers. Again, I am not going to expect you guys to do this on a quiz. You will have to practice it a little bit, but you will not be quizzed on this example 4. So I've just got one last example to cover, and it's modeling. And in my opinion, modeling with math is probably the most useful thing, because it forces you to think about different terms that you'd see in everyday life. So example 5 says, a media download store sells songs for $1 each and movies for $15 each. You have $60 to spend. You're going to write and graph an equation that describes the number of songs and movies you can buy for $60. So first, I'm going to use x and y. I'm going to define my variables. I'm going to define my variable of x for songs I can buy. Y is going to be movies I can. Sorry, that's really bad. Movies I can buy. To write this as an equation, it's representing the entire cost, so a total cost. So it's going to involve some sort of addition. So I'm going to add together my total cost of buying songs and my total cost of buying movies. So the way I represent my total cost of buying songs, $1 a song for X songs, could be 1X. I'm just going to write X. Plus $15 a movie for Y movies. The expression for that, cost of movies, is 15 times Y. So that total is going to equal 60. So essentially, possibilities of combinations of songs and movies I could buy. And these need to be whole numbers, because I can buy a whole song, I can buy a whole movie. So that's our equation. We're going to graph it, and I'll rewrite it so you can still see it. But our equation was x plus 15y equals 60. We talked about this before. Finding the x-intercept, I substitute 0 for y, which would be really just x becomes 60. So my x-intercept is 60. Okay, my x-intercept is 60. My y-intercept, if I substitute 0 for x, it becomes 15y equals 60. So y ends up being 4. My y-intercept is 4. Okay? And if you think about this, kind of think about it in terms of slope. Every time in this line I go down 4, I go right 60. So if I think about it, trying to find another point, every time I would go down 2, I would go right 30. Right? So even going further from that, if every time I go down, and this isn't as important, you just need the 2 points to graph. I'm just doing this so I have more points to graph. Every time I go down 1, I would go right 15. So those are 5 points that would end up on our graph. I'm still going to draw this as a straight enough line, but I'm not going to make this line cross through the x or y axis because only positive values make sense. Oops. So I may ask you a combination of movies that make sense for this problem. If I buy 10 songs in one movie, this would be my point. Now, I'd have enough money, but if I wanted to spend exactly $60, that wouldn't be a solution to this equation. So this would represent spending less than $60. Any point down here. Any point above it, I spent more than $60. So we'll talk about those things later on. We're going to graph inequalities later on. That's what this represents. But right now, just focus on being able to graph using intercepts. And that's basically it, to be honest. That's all you're going to practice today. So we're going to cover standard form a little bit more Friday, but I think standard form is pretty straightforward because you're just finding intercepts to graph it. So you should be ready for practice by now. And then a checkpoint. We'll review this Friday, make sure everybody's ready before we move on.